Hello. Hello. Am I audible?
Yes, ma'am.
Yes, ma'am.
I think we should start now. So in previous lecture, we have started with the concept of array of structure. So this array of structure we are using for creating the database. That array of structure we have gone to create that database, how to display the database, how to search a particular record using the unique field right now we have studied, but you must be able to go using any field, using name, using marks, search. We are going for name. All the entries related to if the name is getting repeated, so all the entries corresponding to that particular name should be repeated. Okay, and in that case, we cannot break here this particular loop. Okay, so if I want to search a multiple record with the same name, so you cannot use this break statement. What will happen in that case is whatever is the first record there itself, it will simply search that one and it will break the loop. Okay, so I just give you the modifications if you want to find out all the records with the same value. Okay, for a particular field, if you are going to check, okay, and we want to get all want to display all the records, we can go for instead break one more way can be any, and I'm making that flag as set. We have to set that as one. Okay, and here flag will be changed to 0. Significant that if your record is not existing in this particular database, so that flag will not change. That means if the record, if this key is not existing, that means for any of the roll number, your condition will not be true and flag cannot be 0 in that case. If flag is 0, that means key is existing and we can say and display that. So in case of multiple, actually wherever the match is found, you have to display, have to take this else part within the if condition only. Okay, so you need to, I just modify and I'll show you. So if match is found there itself, I'm printing comment that record found at location so and so, and corresponding record also we are printing. And final, what will be the condition? No need of else, you need to check that flag value. In that case, I'll check for flag value. If record is not existing, that means your if will not be true for any of the value of I. Okay, and in that case, your flag will be one that we have initialized for. Okay, and if this is flag one, that means there is no change in this flag that represents your record doesn't exist with whatever is the search field that you are using. Okay, so any confusion in this? Is that clear? So with this particular logic, I can go for searching of multiple records with the same value. Okay, is that clear? The difference between previous search and the modifications I have made in this search. So this is apart from key we are assuming as the roll number that should be unique to all the students. Okay, it is unique, it cannot be repeated, so there cannot be the same number, same roll number for two students. Okay, but if I am checking for a particular name in the database, so in that case there are chances that the records are existing with multiple records are existing with the same name. So in that case, you can use this particular logic where I can get the frequency also. Okay, the same logic you can apply to searching a particular number, how many times that number is repeating in that particular uh, array, in a given array. Okay, so to get count actually along with this, okay, so you have to use count. So every time the condition, the match is found, we have to increase the count. Okay, so count needs to be initialized to 0 and increase that count so that you will come to know how many such records are existing with the same name. Okay, so these are few modifications, or like this you can modify the existing algorithms that we have studied for different applications as and how the need application for that particular database is changing. Okay, so with this, we have completed as I told. So we are going for various operations on this database like searching, modify, insertion, delete. So we have finished with these four, and today we will see we have finished with searching, modify and delete, and today we'll go for insertion and append. Okay, so for insertion, I'll just explain you how insertion can be done. Okay, so this is the new table I have drawn here, consisting of roll number, name, and marks, and 8 entries for this table we have considered. Okay, and we have to insert a record after roll number 64. So there are two options again for even for delete or this insertion. You can search a particular record with the required field, and second is you can directly get the location. So which at what location you want to insert that one. Okay, so if we go for after a roll number, so it will include logic for both. Okay, and that's why I'll prefer after a particular roll number. Okay, so if I have to insert after this, okay, so that means I'm searching for a record with the field roll number whose value is 64. So I'll get that for the I equals to 2. For this particular I value, my match will be found. I'm searching that particular record. And after this location, I have to insert a new record. Now I have to insert new record over here. So to insert a new record at this third location, so what I need to do is I need to shift all the records from this third to 7 to the next position. So how it can be done, if I start from this particular location, the location where my match is found, so location next to that match found location, okay, and if I try to shift this third record to the fourth, what is happening? So this complete row get overwritten at location 24. Again, if I shift to this, the same row get copied to the next row. Again, if we just keep on the same flow till we'll reach to the end of that particular table. So we are trying to actually copying the third record, okay, in each row. Okay, and that is not the expected from us to insert new record. So to get that one at to insert new record at this particular location, what we need to do is we need to start shifting the records from the last record. Okay, so whatever is the last record, we know number of records are represented by n. So your last record is always stored at n minus 1th position. So we have to shift this record to the next. That means what we are doing is we are shifting, we are copying our sorry, this is s of n minus 1. So s of n minus 1th record will be copied into s of n. Okay, so once I just copy this row into the next row, so that particular row can be overwritten by the previous row. Now I can shift my previous row, which will be 71 RST and 65. Okay, I'm simply overwriting that one. Same thing is done in memory, so it is changing the contents at that location. So this is how using the same statement. Okay, so n minus 1th record will be shifted to the nth record, okay, nth position. So this is how we can shift initially, and so that all your records will be shifted to the next position, and now I can overwrite my new data at this particular location. Okay, is that clear? Insertion. So now the same thing, how it can be implemented in this 3D program. So we will first write a function for insertion, and then function. I'll call that insertion. Okay. To start with, again, I'll just use this as void insertion function. After adding this record, my actual initial number of records were n minus 1, so which were actually n. Okay, starting from 0, the initial count was n, but after inserting, my count will be n plus 1. Okay, so as the number of records are changing for this insertion also, so for insert function, we are passing the first parameter will be array of structure. Okay, and second is it should be pointer because it's changing the value of n. Okay, and that original n we are passing from, we are calling that function in main, and we are passing that particular n value from this main function. Okay, so I'll write for all this function. Okay, for this insertion, search logic will be same. Okay, I'll just copy paste that search. Okay. So here, let's star m pointer we are using. So reading here number after which we have to insert a new record. Enter a roll number after which we have to insert a new record. Okay. So after this, we are reading that particular key, and we are searching for the key, the location where that search is found. Okay, I'll add here itself. Now what we'll do is you can either modify here or you can simply break and use the same for loop. Okay, same if else statement and same for loop for inserting our new. So this is my end of for loop. If my match is found, we are breaking this loop. That means at this location, at this index value I, which is nothing but here it's 2. Whenever that I equals to 2, your for loop will be terminated. Okay, so when we will come out of that for loop, I value will be 2. Okay, and now at from this location I equals to 2, we have to shift all other records to the next position. Okay, but shifting is we have started from n minus 1, and that is carried out till I plus 1. Okay, still the third record should be shifted, not the second. We don't want to shift this second. After second we have to insert new, so shifting is carried out till n equals to 3, I equals to 3. So to just implement that loop, okay, if I equals to star m, that means I have executed this loop completely, but still I have not found that match. So it is representing your record is not existing. If it exists, my J should start from, the J loop should start from n minus 1. Your last record, number of records are m. As array indexing starts from 0, your last record will be at star m minus 1. So my loop should start from star m minus 1. It should continue till j is greater than what? I plus 1. I we want to insert that one. So till it is greater than equals to I plus 1 because we want that I plus 1th record also should get shifted to the next location. You can go for greater than I or greater than equals to I plus 1. So understand I plus 1 greater than equals to I plus 1. We have started from 7, then 6th record we are shifting, then 5th, then 4th, then 3rd. And after 3rd we should stop. Okay? That means starting from higher value we are going lower value. So this should be j minus minus. Is this your n minus 1th record, that is the current value jth record should be shifted to next position, not to the previous one. So this record, the jth record get assigned to 1th record using this statement for every value of j. If j is 7, that will be shifted to 8. If 6, j minus minus, that 6 will be shifted to 7, then 5 will be shifted to 6, 4 will be so on. So this is carried out till j equals to 3. When j equals to 2, loop get terminated, we will come out of this else. And at the end of this insertion, as we are going to, okay, before shifting, after shifting this one, now I have to add your record to I plus 1th position. Okay, so I is the location after which we have to insert a new record. So this for loop is used for shifting all the records, and once you have shifted, add a new record and dot enter a new. So here we are trying to scan that new record corresponding to the location I. Okay, my scanf will be not ith but I plus 1th location we want to insert that. Fields, all fields. So the first is role, then second is your string, and third one is percent s percent f. And where I want to add those one, where I'm going to read the values s of I plus 1, not at I. Remember, after I we have to insert a new record. The I is the location of a record after which we have to insert new one. So this should be I plus 1th record dot row. Then next one is string. So no if I am putting I plus 1 dot name. Third is again it's marks field float. It's a number. So I am percent s of I plus 1 dot marks. Okay, so this is how insertion statement is. Actually, you can get this complete else part before break also within the if wherever your match is found. Okay, so that is also possible, or you can just go for if else. So if you are taking this else part within if itself, within that for loop, wherever you're searching for a key, okay, so in that case, after for loop, only one if condition, only the condition you need to check is for record exist or not exist. Else part is not required. So any way you can implement, and this is the complete function for insertion. I'll just show you the complete function. Go through that function, and if you're having any doubts in that function, discuss. Then we'll execute this. Is it readable? So, mhm. So this is the complete insertion function. Just go through this, and if you're having any doubts in this function, you can ask. Yes, any doubt? Anybody is having any doubt in this? Yes.
No, ma'am.
Okay. If no doubts, I'll add that append. We'll discuss append function, and both I'll execute at the end. Okay. So the last function that we have to perform on this database is we have to append. Okay. So as you know, initially we have decided the size, some fixed size as 100 or 10 or something, and we have entered only 7. So you can keep on appending, adding data as the new entries are coming. Okay, new admissions are going on, so we can say as the new students get added to the class, so we have to add that student at the end of that particular table. So how and this adding or putting a record at the end is known as, it is known as append operation. Okay, so how we can append that one? So to append any number at the end or any record at the end of an array, okay, to the end of that particular table, we know the existing number of records. Okay, we have to simply, if there are n record, a new record will be added at n plus 1th location. And after adding, similar to insertion, okay, so insertion is we are deciding the location where we have to insert that particular person, okay, or that complete record. Okay, whereas append is without moving, without shifting, or without disturbing the existing table, we have to add, insert a new record at the end of that particular table. And that end is always represented by n plus 1. After adding record, size will be again changed from n to n plus 1. Okay, so as size has changed n plus 1, it should be again updated to your main function. Okay, and for that, again we are using, for this append function, your second parameter that we are using for append is, okay, so first parameter is array of structure. No need of this struct because we have used type def append student as array, and second is its pointer, okay, which is getting address n variable from main. N is representing your number of records, and now I have to add a new record, okay, at the end. So I'll use same printf scanf. Okay, so before scanf, don't, as I'm writing this in Eclipse. So here also we need to add that under threshold. Okay, here also you need threshold before scanf. So this is simple actually, the append function, but after scanning that n plus 1 so actually your last record is at m star m minus 1 because our indexing is starting from 0. Okay, so your last record is at star m minus 1. So this particular location is represented. So this particular location is, it is nothing but it's star m minus 1. So star m is what value? This is representing value at address of n minus 1. So value at address of n, that is value of n. So value of n here is, currently it is 8. So 8 minus 1, sorry, currently it is 9. Okay, so 9 minus 1, it is representing this 8th location. Okay, and hence your new location should be added to star m, which is nothing but 9. Hence, so only the modification that you need to do here is enter a new record that is to be appended in, and that record should be added to the mth position. Nth position. That nth position we are getting through a pointer. Okay, and hence the index value is represented by star m. And after reading this, your star m should be increased by 1. So star m plus 1. Okay, and as it is pointer, whatever plus 1 operation you are performing on pointer will be automatically updated in this table. Okay, now we have completed. This is very simple. Append function is simply at a time we are reading one record and adding that to the end of the table. Okay, so insertion, making space for a record to be inserted, and that is done using this. And before making space, we are asking user where you exactly want to insert that one, after which key, searching for that key, getting the location of that record, and after that record we want to insert. Okay, so if it is if we are directly getting the reading the location, only the changes here itself, there is no need for this for loop. Okay, so yeah, if you're getting if you're reading the location, no need of this for loop and if condition, directly I can start this for loop, where for loop you need to shift all the records from the last record till j greater than equals to location. Location is representing the actual location where you have to insert your new record. So only the changes, all this searching part is not required. Only this for loop and increment your number of records by 1. Okay. So that's all about your insertion and append. I'll just add those two functions here. I'll show you execution, insertion and append also. Here we are calling in which we are passing parameters. One is array of structure, another is a pointer variable, and after insert again okay. For display it also requires parameter, but n is passed by value. Same way I need to define your case 5. Okay, control and change the and here function. So append is also the number of actual records passed as parameters. We need to declare those. That is why you're getting that error. So insert student. Student here is not a variable. Remember, it's the data type that we have created for the structure we declared at the beginning of this program. So and next is the function for append. This is append student array, okay, and integer pointer. Types of data that we are passing as a parameter. Okay, so I'll just save this one. We will build it. So display, it's giving me some error for display. Okay, I'll delete this debug first. Yes, I think it's a warning in search. We have done something in search. Okay, I'll execute and let us see what will happen. We have to now just check our insertion and append function. Okay, so I'll enter only two records here: roll number, name, and marks. Again, we have to enter a roll number, name, and marks. Okay, so this is what has been displayed. Now we want to, we have added case number 4 as insertion. I'll check first 5. I'll enter 5 for append. Enter a new record. So I'll add that new record. So this is what is added at the end. We have executed append function. I have called that append function, and at the end it has just added that. Okay, it is giving me wrong choice also because I forgot to put that break, so that after that case 5 it has executed default also. Okay, remember, if you don't put break after a particular switch case, execute all the cases defined after that case number. Okay, well, to continue this, now we want to check for delete. Okay, not delete, insert. Okay, so we are going for option 4. Enter a roll number, after which we have to insert a new record. So I'll just write 8 and we will enter a new record as 7. Okay, and the marks. Okay, and you can see your new record has been added just next to roll number 8. Okay, so this is how you can perform operations on the database. Is that clear? We have finished with all the operations on the database. Again, I'll repeat, what things you should know in this is you must be able to know, you must be able to declare a structure for a particular application that is asked to you. You must be able to decide what are the different fields. So you must be able to differentiate between structure member. You must be able to differentiate between structure data type and structure variable. Okay, structure data type and structure data type and structure name. So you must be able to differentiate between these two also. Okay, so next, once this is clear, you must be able to know how to access the structure members. So how to access that dot operator we are using to access structure member. So to access any structure member, you require, you need to declare first structure variables, and through that structure variable using dot operator, we are accessing structure members. Okay. The second thing, if the variable for a structure is pointer instead of dot operator, we are using arrow operator to access structure members. Okay. So these are the fundamentals that you should know related to a structure. And after this, the second part that you should know is how to pass a structure to a function. So all these examples are representing how to pass a structure to a function. Actually here we have passed array of structure to a function. So all these are representing passing array of structure to a function. Okay, and just again here for this particular program, we have implemented concept of call by reference for representing of updating your record, number of records. So, and somewhere we have used here star m, pointer m, and somewhere it is used without pointer. So that also you must be able to understand when to use or pass a variable by value and when to pass a variable using reference. Okay, so that's all. So these are the various concepts that we have studied related to structure. Okay, so any doubt in this?
No, ma'am.
Silence is representing no doubt. Okay, so with that, now the next thing is uh, few more things that we will see related to your structure. Okay, and then I'll switch to union. Okay, what do you mean by union and structure and so just a few things are like how to define a structure within a structure, and if we are defining structure within a structure, how to access that particular structure. Okay, and here actually the two arrays that okay, I'll take this declaration avoid. Okay, so this is not defined using type def. So if it is not using type def, I need to use that struct keyword. St is the structure name, and we are using student here as the variable. Okay, array of structure is used to represent array of structure. This declaration or this line is giving you array of structure, but if a particular member is defined as array, so that is representing a member of that structure, which is an array. Okay, so this is array within structure. For example, name that we have defined, the employee name that we have defined as a one of the field, which will be array of characters, and that is the array within a structure. Okay, array within a structure to define a particular field, and this is array of structure representing number of records related to that particular structure. These are few questions which can be asked at the time of oral. That is why I just cleared. Otherwise, it is quite clear that whatever variables you declared within this particular structure, those are known as structure members. It can be array. So structure member can be array, structure member can be structure itself, structure member can be union also. Okay. So any one of these can be a structure member apart from your integer, float, and character data type. Okay. Now we'll see how we can define a structure within a structure. So this is a structure called salary, and within that structure we have defined another structure. Okay, which defines these three fields, that is DA, dearness allowance, house rent allowance, and a city allowance or city. Okay, so these are the various fields of another structure that we have defined. Or sometimes we need to create a date, so that date, date, month, and year. So those three fields can be the part of this structure, even though all these are of the same times, but we want to relate. So all these three fields can be considered, can be defined initially with a particular structure. Okay, and this is how we are inserting that within another structure. So you can assume, so this character structure salary. Now here salary is the name of structure, employee is the variable of a structure. We are not using here type def. So in that case, the identifier that you are using in between closing of structure and semicolon is giving you variable of that particular structure. Similarly, for this inner structure, allowance is the variable. And for this nested structures, okay, if I have to access this particular field DA, okay, so that can be done through a structure called as a structure variable called employee. So you need to call that, use that structure variable employee. So I can access that particular member DA using your outer structure or the main structure employee, main structure variable employee dot now this structure member. So this complete structure is member for employee. So how to refer this complete structure? Using its variable. So variable for that particular structure is allowance. Okay. So after that we have to refer the member of that allowance. Okay, and the member of allowance is again another dot and DA. Okay, so this is how you can refer member of next state structure, and this is how we can define a structure within a structure. Actually here it is directly define that structure. Okay, I can simply define structure outside. I'll try to show you in this. I'll just copy paste the same thing, and just to differentiate I'll just same code again, and the different way to declare structure as a member of this structure salary is that you can define that structure first. Okay, so give you here you need to specify the structure name. So allowances are done, and this simply allow is we will consider as a variable for that. Or actually when you declare here a structure, no need of any variable, and add this structure variable for allowance. Okay, done using struct allowance and the variable name specified. Okay, so this is how you can define this structure. So declaring or this structure declaration is very similar, or interpretation of this particular structure declaration is same as whatever is we have discussed or represented in the first part. Okay, so this is what is called nesting of structure. You can define a particular structure as a structure member for another structure declaration. Okay, so similarly your union can be the field of this structure, or array of structure can be the one of the member for another structure. Okay, so anything is possible. How to access in this case? It is cascading of two structures. So you have to consider outer variable first, then inner variable dot inner variable, and then the members of that particular structure. Okay, is that clear? It is represented employee.allowance.da, employee.allowance.hra, and so on. Okay, clear? Nesting of structures. I think that's all. This is also very clear. So this is all about your structures and arrays of structures. Okay. Having any doubt, you can stop the ask. And if not, I'll start with this unions. So what do you mean by union? How and how it is different from structure, and what is need of union? Okay.
मैम
So basic.
स्ट्रक्चर्स जो होते हैं वो डिफरेंट मतलब जैसे एरे होता है वैसे एक मेमोरी लोकेशंस पे स्टोर करते हैं, यूनियन एक ही स्टोरेज लोकेशन पे सब कुछ स्टोर करते हैं.
Yes, yes. So we are going to discuss that union. Okay. Uh, okay, that was true. Okay, that is true. So union is what? It is very similar to structure. It can be defined as a collection of different data types. Only the difference, as just now I think he was Abhi told, ki union occupies the same memory location. All the members of the union share the same memory location. So how much memory will be allocated for the union? So that is decided by whatever is the maximum size of data type that you are declaring as a member for that union function. For example, here this is representing your union consisting of integer, float, character. So the maximum memory that is allocated for this particular is your float. Okay. Now I'll try to represent this memory representation for union. Okay, and structure. Okay, assuming the same structure. Okay, integer m, float x, and character c. If it is structure, you can just imagine. instead of union if it is structure. So in case of structure, the memory that is allocated will be separate memory. So for this, it is for integer, for float, and for character. So 1 byte for your character C. Okay. So what are the other variables? M and X. So this is your integer variable and X is float. So for float 4 bytes and for integer also we are assuming 4 bytes. So this is what is your memory representation for structure declaration for the same for which we have represented union. Okay. But in case of your union, so it will take only 4 bytes. Okay. So the same 4 bytes will be shared by your M, it will be shared by X, and out of these 4 bytes, the first byte, okay, will be shared by your C character. Okay. So this is what is your first byte. So this is 1 byte like this. 4 bytes will be allocated for this complete union, and out of that your first byte will be occupied by will be shared by C, whereas this whole data has been shared by M and X. So that means I can access at a time only one variable. Okay. And based on that, whatever are the values that you are using to initialize those union members, so it will give me the corresponding value. Okay. For example, now I will show you again the example for this union. Okay. So here union is defined where integer I and character for two character array with two characters are represented. The maximum size is 2. Okay. Store two values there, and here we have represented how to access, or we have initialized only I for 512 and trying to access the character values simultaneously. Okay. So trying to print the I value and character value printed as %d as integer. That means it will print the ASCII value corresponding to your character 0. Okay. Now I'll first represent how this 512 will be represented in memory. So the binary equivalent of 512 will be, okay. So I think you might be knowing that one, okay, but still. So memory representation for this 512, we have initialized key dot I to 512. So internally it will be stored as first 4 zeros. This is your 1 byte and another byte. Okay. So this is uh, this complete 8, 9, 10 2 raised to 9 is giving you 512. Okay. So this is it starting from 0. It is at ninth location. So 2 raised to 9. So this is what is the binary representation for your what we can say the integer value I, and the same memory location is being shared by your character 0 and character 1. So in memory always the lower byte will be stored first and then higher byte. So character 0 is nothing but it is representing this byte, the lower byte from 512, and character 1 is nothing but the higher byte from that particular 512. So when I try to print the value of ch of 0, so actually what I am getting is corresponding to this 0, 0 should get displayed, and corresponding to this character 1, the byte that this character 1 is having, the value that character 1 is having is this binary combination, so which is giving us 2. So we will just check, and when we try to print the integer value corresponding to this key dot I, so it should print us, it should give us 512. Okay. So is this presentation? Before that all zeros, but those zeros are not shared by 4 bytes. That means this is 1 byte, second byte, and remaining 2 bytes are represented by all zeros for this integer I. And out of these 4 bytes, the lower 2 bytes will be shared by your CH0 and CH1. Okay, and this is how their integer values will be corresponding to the binary combination. Okay, and this is how actually the memory sharing will be done through union. Okay, so it is already built. I'll directly run it, and you can just see, as we have discussed, I'm getting this character of 0. Okay, this also giving me 0. uh, but you can just differentiate your second printf, which was character of 0 equals to percent %d is 2. So this is representing your character 1. Okay, and key of I initialized to 512. So that is 512. The lower byte from that 512 is nothing but the value for this key, and I'll show you. Okay, with this correction also we'll try to print the corresponding character value. Okay, I'll add instead of integer. If you want to check what will be the actual characters for that, for those numbers. Okay, yes, that's built, and this is what you are getting. For this character 0, we are not getting anything, and this is what is the question mark. So corresponding to 0, actually it is null, so it's giving us nothing. Okay, and character of 1, it is giving me something. This character is represented with value 2. Okay, so that means the same memory location. So this actually, from this we can say that union is sharing, the union members are sharing the same memory location. The rest everything is similar to your structure. Instead of structure, we are using keyword union to declare a union. So you need to specify structure name if you are not using type def, and if you are adding here type def, that is optional union name, but you need to define the data type before ending that structure before the semicolon. Okay, so here your data type will be set. Okay, and instead of this union A, now I can use that keyword union data to declare your union for this particular union. So it can be accessed, it can be used very similar to your structure. Okay, so in this case we have created user defined data type with name union data. Okay, and this is how it is giving you an example for sharing of the memory location. Now the proper application where the need of this particular unions are required, I'll add that example and try to explain that. For example, I wanted to find out power of a number x raised to y. If y is integer, I can directly find out power by multiplying x for y times. But that is not possible if your power is float. Okay, so there we have to go for log and all those things, and we need to find out e raised to power or whatever is the suitable expression. So based on that we need to find out that x raised to y. So in that case I can define my union consisting of integer as well as float. Okay, and based on your application, if your application is using power as the float number, so it will access the float variable, float member of the union, and if it is integer, it will access the integer member of that particular union. So this is one uh, practical example I try to put in front of you. If you can imagine, just think of, otherwise I'll add that complete example in this slide and I'll share with you. Okay, and with this we have completed our structures and unions. If you're having any doubt we can discuss, otherwise I can say now from this unit your hashing part, that is searching a particular record or number using hashing technique, that is remaining, and second thing is file handling. So these two topics are remaining. and a few things related to bitwise operator I want to explain you. If possible, we will try to cover this in the next lecture, in tomorrow's lecture. Otherwise, I need to think whether we can start with the third unit, because in next week again we have to start with the next experiment. So I'll just check how it can be managed. Okay. So tomorrow, going to cover hashing, definitely hashing and bitwise operator. Okay. So that hashing is also one of the important topic for the campus interviews. Okay. Mostly it will be asked in the campus interviews. So with this, I would like to end this lecture. Okay. So if you are not having, I'll end this lecture. Okay.